Here's what you're going to do. You're going to take notes and follow along as we go through this lesson. First thing I need you to do is write down the title. The title is Lesson 3, Periodic Trends. The next thing you're going to do is write down that essential question. Your essential question is, how can you use the periodic table to predict an element's properties? That's important because you're going to notice that certain elements follow specific trends on the periodic table. Now, let's review a little bit of what these trends are and where things are located in the periodic table. So up here, I have a periodic table. All right. Your periodic table is organized in groups and periods. There's period 1, period 2, 3, 4, 5, 6, 7. So there's 7 periods, and the periods are the rows. Period are the rows. Now, there are 18 groups. All right, so there's 18 groups. Group 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 groups. And the groups are the columns. All right, groups are columns. Now, these groups and periods can be organized in different ways. The first thing is metals versus non-metals. If you look at this periodic table, anything written in purple right here is a non-metal. Non-metal. Anything written in green is a metal. And then anything in yellow is a metalloid. Metalloids are a little weird because they have properties of both a metal and a liquid. Next, we're going to talk about the different groups. Remember that anything in group 1 is also called an alkali metals. Alkali. Anything in the second group is the alkali earth metals. Anything in this middle block is going to be called a transition metal. And finally, we have anything in this column right here, which is a halogen. They're the most reactive, halogen. Remember, halogens are the most reactive. And finally, anything in this final column is your noble gases. Noble gas. Make sure that you memorize this table. As a friendly reminder, you also have the lacantonides and actinides. This row is the lacantonides. Lanthanides. And you have anything here, which are the actinides. actinides. Don't trust my spelling when it comes to lanthanides and actinides. All right, lesson 3, periodic trends. The first type of periodic trend is going to be atomic radius. Atomic radius refers to the size of the electrons orbiting outside of a nucleus. Atomic radius is usually going to decrease as it goes from left to right, but it also increases as you move down a group. And the reason why is because of an electron configuration. All right? For example, if you have something like helium, helium has a very small electron configuration. Its electron configuration is 1s2. And so naturally, helium is going to be pretty small with 2 little electrons. However, if I'm going to compare helium to something like francium, francium is going to be huge because francium has a large electron configuration. By the same caliber, if I have something like sulfur, sulfur is going to be much bigger than helium with an electron configuration of 1s2, 2s2, 2p6, 3s2, 3p4. All right, and so sulfur is going to be much bigger than helium because it has 3 orbitals instead of just 1. See that? Sulfur is much bigger than helium. 1, 2, 3, 4, 5, 6, 7, 8 electrons, 2 here, and then 1, 2, 3, 4, 5, 6 out here. All right, so go ahead on your own. You're going to solve this problem and tell me what you come up with. Which has the largest atomic radius and which one is going to have the smallest atomic radius. Next, we're going to talk about periodic trends, or we're going to talk about the increasing atomic size. As you can see, atomic size increases as you go from left to right and decreases as you go down. Something like strontium is much bigger than something like aluminum. Aluminum is smaller than strontium, but it's all going to be relative. You can see a visual of this on the next slide where you can see all the elements listed out by size.